Hello everyone. Let us see how to prepare a spreadsheet or the Excel sheet for single reinforced beam design. For that, I have taken a problem that is a rectangular beam is to be simply supported supports of 230 mm width. Width of support is given. Clear span of the beam is given as 6 meter. The width of the beam is given as 300 mm. Then lay load acting on the beam is 12 kN per meter. M20 grade of concrete and Fe415 steel is given. So by considering all these parameters, we have to design the beam. Here the manual calculation is provided for the design of single reinforced beam. The same thing we will execute in the Excel sheet. Let us see how to prepare the spreadsheet for design of this single reinforced beam. So here we need to first write all the given data like width of the beam. Depth of the beam you need to choose as 1 by 12th to 1 by 15th span. Here it is there. Width of the beam is given in the problem only, that is 300 mm. Now you need to choose the depth based on the range between 1 by 12th to 1 by 15th of the span. Clear span is given. It is given as 6 meter. In terms of mm, it is 6000 millimeter. So 1 by 12th of 6000 to 1 by 15th of 6000 means it will be between 500 mm to 400 mm. I have chosen 400 mm as effective depth of the beam. So here the same value I have written here, 400 mm. Then cover I have assumed as 50 millimeter, and overall depth will be effective depth plus effective cover, that is 450 mm. So how to get this 450 mm? Just is equal to 400 plus 50. If we type, we will get 450 mm as a overall depth. Then width of the support is given in the problem. Directly you type it as 230 mm here, and in one more column I have converted all these values from millimeter to meter. How to convert means, here you can see 300 mm means it is 0.3 meter. Just click on this cell, is equal to 300 divided by 100. If you type, you will get, sorry, 1000. 300 divided by is equal to 300 by 1000. If you type, it will get converted into meter. Similarly, if you want to convert this 400 mm to meter and 50 mm to meter, just you drag down, it will automatically calculate the, it will automatically convert the values, other values from millimeter to meter. Okay, you will have to just convert one number into from millimeter to meter, and just you need to drag down so that other values will be get converted into meter. So these values are needed for the further calculation. Okay, so here I will type once again all the data: 300, 400, 50, 450 and 230. Once again I am typing here how to convert this 300 mm into meter is equal to, I will take this new value, 300 divided by 1000, enter, just drag down, you will get all the remaining values, converted values into meter. Then what else is there? Grade of concrete is there, FCK, that is 20 Newton per mm square. Here you can see a drop down list from which you can directly select this grade of the concrete. I'll make all these values red because these are all input values. You need to give the input of all these values. Okay. Then here you need to create a drop down list here. So how to create? Let us see how many from M15 to M40 the list is there. So you need to somewhere you need to type all these values. 15, 20, say up to 40 means just add down up to 40. Now you need to create a drop down list here. Let us create. Click on this cell, then go to data option. In the data option we have a option called data validation. Click on data validation, then again click on data validation, then here in this drop down list you select list option. So you need to upload the list through this arrow mark here. Click on this, then click all the numbers from 15 to 40. Again click here, say OK. Now the drop down list is created. 15, whatever the FCK value that you want as per given in the problem, you can select it. Okay, now in this problem M20 is given. I'm taking M20 grade carbohydrate. Similarly, for Fe415 you can create the drop down list. Somewhere you need to make the list of 250, Fe250, Fe415 and Fe500. Here if you want to create the drop down list of this grade of steel, then same thing, go to data validation, then you take list, upload the values, say OK. Drop down list is created. So in this problem Fe415 steel is given. I am selecting Fe415. So this is how we have to create the drop down list. Then clear span, it is given in the problem only. I will type as it is 6 meter. Then to calculate the effective span, you need to calculate the effective span in two ways. One is center to center distance between the supports. Second calculation is clear span plus effective depth. Okay, now first we will calculate center to center distance between the supports. See, here I written the diagram. Center, the width of the support on both the sides of the beam is 230 mm, which means 0.23 millimeter. So center to center distance between the supports will be 6 meter plus 0.23 divided by 2 plus 0.23 by 2 on either side. So you will get the total center to center length as 6.23 meter. Therefore here is equal to 6 plus 1 width of the support. 1 width of the support is how much it is 0.23 meter. Click on 0.23, press enter, it will get calculated. Then one more calculation, clear span plus effective depth. Clear span plus effective depth. Effective depth, where we have the effective depth here, effective depth is 400 mm. Here we have got it as 400 mm, which is nothing but 0.4 meter. In terms of meter it is 0.4. So wherever it is required to calculate in terms of meter, you need to use this 0.3, 0.4, means all these values which are converted into meters. Wherever it is required to use the values in terms of millimeter, you need to use this red numbers. Okay, so here one more way of calculation of effective length is clear span plus effective depth. Click on this cell, go here, is equal to clear span is 6 meter plus effective depth plus 0.4 meter. Type and press enter. Now you got two values, from two different calculations for effective span. that is 6.23 meter and 6.4 meter. So out of these two calculations, you need to choose the minimum value. Now the question comes, how to choose the minimum value in the Excel sheet. Click on the cell, type is equal to you just click minimum min. Here you can see an option popping up. Here double click on this option min, double click of these two numbers, select both the numbers, press enter. Now the minimum value is selected automatically. So this is how we calculate the effective span. Now the effective span is 6.23 meter. Okay, and coming to the design moment and shear, the live load acting on the beam is given, that is 12 kilonewton per meter. Then self weight, how to calculate the self weight? Cross sectional area multiplied by density will give self weight. This 12 kilonewton per meter given in the problem only, problem of the live load, and self weight is calculated as cross sectional area multiplied by density of the concrete. Cross sectional area means width of the beam into overall depth of the beam will give cross sectional area multiplied by density of the RCC, density of the reinforced cement concrete, that is 25, will give self weight. Okay, self weight of the beam. Now here self weight is equal to, click on this cell, is equal to cross sectional area means overall depth. Okay, not the effective depth, you need to take overall depth, width into, in terms of meter you need to take, because here the density of the concrete is 25 kilonewton per meter cube, therefore you need to take the values in terms of meter, not in terms of millimeter, is equal to, here the width of the beam is 0.3 meter into overall depth is 0.45 meter into 25, density of the concrete. Cross sectional area multiplied by density will give self weight, that is 3.375 kilonewton per meter. Then total load will be sum of these two values, correct? Sum of these two values, just type is equal to this plus 3.375. Now it is giving total load. After total load we need to calculate the factor load by multiplying the total load by 1.5. Come to this cell, type is equal to 15.375 into 1.5. Now it is calculating factor load. Then what else? Bending moment and the shear force. For bending moment we have the formula WL square by 8. For shear force we have WL by 2, where L is effective length in terms of meter. Okay, therefore first we will calculate the bending moment, WL square by 8. W means this factor load. Click on the cell, type is equal to WL square. W into L means effective length, 6.23 square. For square you type shift 6 in the keyboard, type square divided by 8. You put a bracket here, divided by 8. So it will give bending moment. Here you can see so many digits coming here. You can reduce it. Click on this number. Here click on decrease decimal. Okay, 311.89 kilonewton meter. Then shear force formula is WL by 2. Correct? WL by 2. Come to this cell, is equal to WL by 2. W is factor load into effective length 6.23 divided by 2. Type enter. So it is calculated, that is 17.84 kilonewton. Okay, this completes the calculation of design moment and the shear. What next after this? After this, there is check for section, that we will not. I'm not going to do it directly. I'll be going for the next step, that is calculation of area of the steel. So it is calculated based on the formula which is available in page number 96 of IS 456. The formula is written here. M is equal to 0.87 Fi AST into D into 1 minus AST by BD into Fi by FCK formula. You will get a quadratic equation. Okay. After solving this quadratic equation, you will get the value of AST. So here what we have to do? We have to calculate the coefficients of this quadratic equation here. Coefficients of AST we need to calculate here in the Excel sheet. After that we can calculate the AST. See here you can see it is in the form of quadratic equation. It is in the form of quadratic equation, which is nothing but ax square plus bx plus c is equal to 0. It is in the form of ax square plus bx plus c is equal to 0. After solving, you will get the value of x, where a, b, c are the coefficients of x square, x, and the constant. Okay. Initially, in the Excel sheet, what we will be doing is we will be calculating all these coefficients, a, b, c coefficients. See here, coefficient a is nothing but, you can see here, coefficient a means this 24.97 AST square. Okay, this 24.97, how it has come means by multiplying 0.87 Fi AST into D into AST into Fi divided by B into D into FCK. Multiplying all these things, we will get this coefficient of AST square. Okay, and coefficient of AST means only this much, only this much. So this is the coefficient of AST multiplied by 1. Okay, we will get 1,44420 into AST. Let me show you. So here, coefficient of AST square means 0.87 into 415 into 400. This is coefficient of AST 1,44420. Coefficient of AST square, again the same value multiplied by into 415 divided by 300 into 400 into 20. 300 into 400 into 20. 24.97. Okay, and C value is whatever the moment value we have in the LHS, that will be C value. Okay, the same thing we will use in Excel sheet. And one more important thing, here you got bending moment now. Bending moment, after getting the bending moment in terms of kilonewton meter, you need to convert it into Newton millimeter. How to convert? You just need to multiply by 10 power 6. Okay, so here I'll convert that kilonewton meter into Newton millimeter is equal to this into 10 power 6. 10 power 6 means 6 zeros. Now it has got converted. I'll reduce the decimal. And similarly, shear force will be is equal to 71.84 into 1000. Okay. Now we have the shear force and bending moment values in terms of kilonewton meter as well as Newton millimeter, kilonewton and Newton. Okay. Now first we have to calculate the coefficient of AST square, that is 24.97. Okay, how this 24.97 has come? By multiplying this all these values 0.87 into 415 into 400 into 415 divided by 300 into 400 into 20, which is nothing but 0.87 Fi into dE into AST. AST is unknown into Fi divided by BD FCK. Okay, so we have to give the same input here is equal to coefficient A is equal to what is there 0.87 into Fi. Fi is 415 into D. Effective depth is how much? 400. Okay, 0.87 Fi into D into AST into Fi again into Fi. Okay, into AST divided by FCK into BD divided by FCK into BD. FCK, where we have the FCK here, 20 FCK into B into D, width into depth, 300 into 400. Now you can see 24.97 is the answer. Okay, next coefficient B. So with negative sign you need to take is equal to, so you need to click on this cell, is equal to minus 0.87 Fi into AST, 0.87 into Fi. You click on Fi, AST into D. AST is unknown into D, effective depth 400. Now you are getting answer 13420. And see whatever the moment value you have, same thing you need to bring here. Click on this cell, plus is equal to, click on this value, enter. Now you got C value as well. Now you need to calculate AST1, AST2. Okay, you need to calculate you need to solve this quadratic equation now. You need to solve this quadratic equation. So we have a formula for calculating the roots of a quadratic equation, that is minus b plus or minus root of b square minus 4ac divided by 2a is the formula. Using that formula we need to calculate the roots of the equation. Okay, so here I will give the input of that formula. See here you can see minus b plus square root of b square minus 4ac divided by 2a. This is one root. Second root is minus b minus square root of b square minus 4ac divided by 2a. Let us calculate here. AST1 is equal to minus b, open the bracket, minus b minus b means this one minus b plus square root. For calculating the square root, you need to type as sqrt. Here, after typing sqrt, you will get an option below. Double click on this square root of b square minus 4ac. Okay, b square minus 4ac means same value b square once again minus 4 into a means 24.97 into c, this value, close the bracket, minus b plus square root of b square minus 4ac is calculated, divided by whole divided by, again open the bracket, 2 into a 24.97. Type enter. Minus b plus or minus, just a minute, minus b plus square root of b square minus 4ac divided by 2a minus b, let us refer here, minus b plus square root of b square minus 4ac divided by 2a. Let us redo it once again. Somewhere it went wrong. Is equal to minus, open the bracket, minus b minus b plus square root, double click on square root of b square minus 4ac, b square minus 4ac a c, close the bracket, divided by 2 into a, 2 into a. Now type enter. Now you are getting the answer, that is 4861 millimeter square. Similarly, AST2, for calculating the AST2 means second root, just there will be change in the sign. You click on this cell, copy the full formula, copy, press escape button, click on bottom cell, here control V, paste the same formula. You just change the sign here, minus b minus square root of same b square minus 4ac divided by 2a, press enter. Now one more root is calculated, means one more AST is calculated, that is 922 millimeter square. Okay, now one AST what we have got is 4861 millimeter square, and one more AST we got it as 922 millimeter square. So practically 4861 mm square means very large value. Practically it is not possible to provide that much AST. You need to choose the minimum value here. To choose the minimum value means provided AST should be with a minimum of these two answers. Okay. Therefore, here click on the cell is equal to minimum of double click on MIN these two values. So it will automatically select the minimum value of 922. Now next step is you need to choose. Now you got the AST, okay, to be provided for the beam. Now choose the diameter of the bar. Diameter of the bar varies from 10, 12, 16 up to 20 mm, more than 20 also sometimes, of course, sometimes provided. So we will create a drop down list as we created before for F6 and F5. Somewhere here you type all the diameters. Here how many is created? 10, 12, 16 and 20. I'll create this same kind of table here. 10, 12, 16, 20. Okay, here I'll create drop down list now. Go to data validation, list, upload the list now. 10, 12, 16, 20. Save. Okay, now it is created. Now I am choosing 20 mm diameter bars. If you choose 20 mm diameter bars, area of one bar will be pi d square by 4. Type is equal to pi means value of pi is 3.142 into d square, 20 into 20 divided by 4. So you will get 314 mm square. Then now you know total area of steel to be provided. You know diameter of the one bar. Okay, diameter of the bar. Then you also know area of one bar. The total area of steel to be provided divided by area of one bar will give number of bar. Therefore, the number of bars will be is equal to total area of steel to be provided divided by area of one bar. Type enter. Now it is giving 3 number of bars. So we have to provide 3 number of 20 mm diameter bars for the beam. Okay. So this is how we have to do the calculation of the area of the steel. Okay. Next is design for the shear reinforcement. Initially we have to calculate the total shear stress that is acting on the beam. The formula is tau is equal to Vu divided by Vd. Here one more thing, this Vu shear force, ultimate shear force is to be substituted in terms of Newton, and B and D values should be substituted in terms of millimeter. Okay, Vu by Bd formula. Therefore here shear stress is equal to the shear stress is equal to Vu by Bd. Vu we have calculated here 71,840 divided by, open the bracket, B into D. B is how much? 300 into D is effective depth here. Effective depth. Close the bracket. Press enter. Vu by PD is equal to Vu. Vu is 71,840 divided by B into D. P is 300 into 400. Close the bracket. Type enter. it is coming as 1. So in the calculation here it is 0.598, means nearly 0.6 you need to get. Is equal to VU by PD 71,840 Newton. 70,840 Newton divided by P into D. B is 300 into 400. Let us calculate here. See here, the VU value is 71,840. 71,840 divided by 300 into 400. 0.6 is the answer. Oh. So why we are getting 1 means here we have what we have done is we have done this to decrease decimal. You need to, if you increase the decimal, then you will get 0.6. That is why we are getting 1. Okay, it is rounded off to the next full value. That is why we were getting it as we were getting the answer as 1. So in that case, you need to, what you have to do is you need to increase the decimal. Here we have the option called increase decimal. Click on increase decimal, you will get the exact value. Okay, so now the tau v is calculated. Next we have to calculate percentage of the steel. Percentage of the steel means AST provided divided by cross sectional area into 100. Okay, AST provided divided by cross sectional area into 100. See here, the provided AST is 922 is equal to AST provided divided AST provided into 100 divided by B into D. B is 300 into 400. Type enter. Again we can see you are getting the nearest full value. We have to increase the decimal to get the exact value. See, 0.77. It is rounded up to 0.8. 0.8. You have to increase the decimal to get the exact answer. Okay. Now, by using this percentage of the steel, by knowing the FCK value, we can calculate the TOC value from this table. Page number 73 of IS 456. Okay, here the PT value what we got is 0.77. and FCK value what we have is 20. So with respect to percentage of steel of 0.77 and FCK of 20. So it means for M20 grade concrete, here PT 0.77 is there, for 0.75, and for 1 we will get the corresponding value, that is 0.62 and 0.67. After interpolation you can sorry, the 0.56 and 0.62. For 0.77 you can interpolate. So after interpolating, you will get the value in between 0.56 to 0.62. That you need to calculate, and by referring that table, you need to type here. So this red number indicates you need to give the input. You need to refer the table. You need to calculate the corresponding TOC value from the table. You need to enter as 0.57. Whatever the value that you get, you need to enter here. Increase decimal, make it as red. Okay. Now shear force based on the area of steel provided, based on the area of the concrete that we have provided, the shear resistance of the beam is 0.57 Newton per mm square. Okay, the shear stress that is resisted by the concrete is 0.57 Newton per mm square, but the shear stress that is acting is 0.6 Newton per mm square. So we need to do the shear design here. Okay, the shear stress acting is 0.6 Newton per mm square, but out of 0.6, 0.57 Newton per mm square is handled by the provided steel and the cross-sectional dimension which is provided for the beam. Here the shear stress that is acting is greater than the shear stress that is resisted. Okay, therefore we have to provide the shear reinforcement. Okay, now the shear stress resisted by the concrete is how much? 0.57. If you know the shear stress resisted by the concrete, you can calculate shear force that is resisted by the concrete. TOC value is known. Okay, stress is the shear force is nothing but stress multiplied by cross sectional area. Stress is 0.57. You know the cross sectional area, just multiplying the cross sectional area you can calculate the shear force that is resisted by the concrete is equal to 0.57 into 300 into 400. 300 into 400. Type enter. We can see the shear force that is resisted by the concrete. Okay, initially from the table we have calculated TOC, that is shear stress resisted by the concrete. Shear stress resisted multiplied by cross sectional area will give shear force resisted, that is 68,400 Newton. Okay, now uh, the actual shear force that is acting on the beam is how much? 71,840 Newton. Okay, 71,840 Newton shear force that is acting on the beam. Out of 71,840, 68,400 Newton is handled by, is resisted by the provided reinforcement and the cross sectional dimension of the concrete beam. Okay, but the shear force resisted by the beam is less than shear force that is acting on the beam, so we have to provide the shear reinforcement. For how much force we have to provide the reinforcement? 71,840 minus 68,400. Therefore shear force to be resisted by the shear reinforcement is equal to, you click on the cell, is equal to 71,840 minus 68,400. Now for this much force we have to do the shear reinforcement design. Okay, now coming to the shear design, initially we have to select we have to select some die of the reinforcement. Okay, the same thing whatever I have done in the Excel sheet, same thing is shown in the shown in this calculation. Okay, shear stress was calculated, percentage of steel was calculated. From that table, this you need to do the manual calculation. After getting this 0.57, you need to take the same value in the Excel sheet. Then shear reinforcement to be should be designed for uh, how much, that is here I have calculated in terms of kilonewton. So here in terms of Newton I have calculated in the Excel. Okay, in terms of kilonewton it is shear force to be resisted by the stirrups is 3.43 kilonewton. In terms of Newton it is 3440 Newton. Okay, so for this much shear force we need to do the shear reinforcement design. Okay, now coming to the shear reinforcement design, you need to choose suitable diameter of the stirrups. Here I have chosen 6 mm diameter stirrups. So you need to create, you can create drop down list here for choosing the diameter of the stirrups. Somewhere you type 6 mm and 8 mm diameter stirrups. Click on this cell, go to data, then here data validation list, choose both the values 6 and 8, plus here say OK. Now drop down list is clear. Whichever the diameter of the stirrups that you want to provide, that you can select now. I will choose 6 mm diameter stirrups, two legged 6 mm diameter stirrups, that to FE 250 grade. Okay, FE 250 grade. Now the area of the stirrups will be pi d square by 4. As it is two legged stirrups, you need to multiply by 2. First you calculate pi d square by 4 is equal to 3.142 into d square into 6 into once again 6 d into 2. Why I am multiplying by 2 means it is two legged vertical stirrups divided by 4. So we will get the area of the stirrups. Knowing the area of the stirrups, you can calculate the spacing by using the formula provided in the IS 456 codebook. Here we have the formula. Here we have the formula. Using this formula, we can calculate the spacing SV. See 0.87. The grade of the stirrups. Stirrup steel is known. Area of the stirrups is known. Effective depth is known. Then shear force, ultimate shear force is known. You can calculate the spacing. So SV is equal to 0.87 Fi into ASV into D divided by VUS. Okay. If you modify this formula, if you take SV to the LHS, VUS to the RHS, the spacing SV will be equal to 0.87 Fi ASV into D divided by VUS. Same formula you need to input here. Spacing is equal to spacing is equal to, I will refer this formula, 0.87 Fi is equal to 0.87 into Fy is 250. Okay, 250 into ASV, just before we have calculated area of the vertical stirrups, ASV into D, effective depth 400 mm, D divided by VUS, divided by VUS. Here we have enter. Okay, 0.87 FYS, 0.87 into 250 into, let me calculate once again, 0.87 into 250 Fi into what is formula ASV 57 into D. D is 400 divided by VUS. VUS means 3440. 3440. Okay, earlier in the earlier step I have chosen this uh, ultimate shear force, that's why we got wrong answer. Here you need to substitute the shear force for which the shear reinforcement is to be designed, that is 3440 into substitute. Now we are getting the spacing as 1430 mm spacing of the shearers. There are two more ways of calculating the spacing of the shearers. First one is 0.75 times of effective depth is equal to 0.75 times of effective depth is 300. Click on 300. Sorry, 400. 400. Enter. So 0.75 times of 400 means 300 you are getting. Then one more way is directly 300 mm. Now you have calculated spacing in three ways. First way is using the formula provided in the codebook. Second way is 0.75 times of effective depth. Third is directly 300. Out of all these three values, you need to choose a minimum value. How to choose a minimum value? You just type is equal to minimum, min, you type, double click of all these three values, enter. Therefore provide 300 mm spacing. So to this, the design of the single reinforced beam is over. Okay, now the Excel sheet is prepared. Now you can get the design of single reinforced beam for any other different parameters. For example, instead of width being 300, if you give 350, it will give the corresponding design. It will give the corresponding changes in the design. Okay, so instead of selecting the depth as 400 mm, if you choose it as 350 mm, it will give the corresponding values. You need to change all these red values, means width of the beam, depth of the beam. Okay, cover, you need to give all these inputs. If you give all these inputs, it will give the values, design values. It will give the design values. Okay, so you can change the loading as well. Grade of the concrete you can change it to M25. Okay, Fe500. Whatever the values that you want, you can give as input. Here you can change the diameter of the bars. It will give the number of bars. And here you are getting negative values because here the TOSI value is not based on the table actual values. After changing here, that is why you are getting some different answers here. Okay, to this design of the spreadsheet design of the single reinforced beam is over. If you have any doubts, you can text in the comment section. Thank you.